Another important triangle relationship is this idea of similar triangles. So we would say that two triangles are similar if they have the same shape, but not necessarily the same size. And so what's going to happen in these is you're going to have corresponding angles that are equal. So the angles will all be the same, but the corresponding sides are going to be proportional. So we looked at proportions in a previous section, and so we're actually going to use that some in this section. So you can think of two triangles, and it's hard for me to draw these completely similar, but you could have a triangle A, B, C, and then the corresponding angles would be A prime, B prime, C prime. Sometimes the triangles are going to be drawn in a different orientation, and that's okay too. So maybe you have this kind of right triangle, and if this is D, E, F, you would have to figure out what the corresponding angles were. The easy one is going to be the one that's there that looks like a right angle, and then you can see that the smaller side goes from E to F, and so the smaller side on this triangle would be E prime to F prime, and then that would leave D prime for the other. So you can rely somewhat on your visualization to match up the angles, but to know for sure that these are actually similar triangles, you must show that one of those two properties holds true. Either that the corresponding angles are equal or the corresponding sides are proportional. It is not enough that they look the same, because they could be off by just a little bit, which would make these not exactly similar triangles. But if you look here at example 4, where we have segment DE that's actually parallel to the side of triangle ABC, and by doing that, we actually create these two transversals, and that creates some corresponding angles for us. So by knowing that DE is parallel to BC, that automatically tells us that angle B equals angle D, and that angle C equals angle E. The only other thing that we need is that the third angles are equal, but they're actually the same angle. And so that has to be true. And so by showing that the three pairs of angles are congruent, and sometimes you actually will put a little tilde above that to show that the angles are congruent, not necessarily that the measures are equal. That's not so important in this particular case, but as far as notation goes, that would be the appropriate notation. But here the angles are equal or congruent, and so therefore these two triangles are similar. Having all three angles paired up is all you need.